Number 7, letter A. As blood passes through the capillary bed in an organ, the capillaries join to form venules, which are small veins. If the blood speed increases by a factor of 4 and the total cross-sectional area of the venules is 10 squared centimeters, what is the total cross-sectional area of the capillaries feeding these venules? All right. So here is a simplified picture, and basically the black portion will represent the capillaries, and the red portion here will represent the venules, and we have this idea that the volume flow rate, right, through the capillaries, okay, will equal the volume flow rate through the venules, all right? Now, that conservation of flow here is important because it then allows us to create this simple equation that the volume flow rate through the capillaries is equal to the volume flow rate through the venules, all right? So now, given that that is the case, we now realize that they're giving us areas, right? They're telling us speeds increasing by certain factors. So most likely I'm going to be using this formula as a means to substitute now area and velocity on in for each of the flow rates. So now, expanding on the flow rate here, right? The flow rate through the capillaries would be the total area, all right, of the capillaries. So each of these areas will represent the total area, multiplied by then the average speed through those capillaries. That will then equal the area, the total area of the venules, multiplied by the average velocity through those venules. All right. So now, sorry. Just I'm not really sure what my son's doing. It sounds like he might be power bombing his brother. But in any case, so now here we, so in terms of the equation here, we have, it tells us that the speed increases by a factor of 4. So the speed increases as it moves through the venules, right, compared to the capillaries. That's what that is telling us. So in other words, right, the speed through the venules, the velocity that is 4 times larger than the speed, aka the velocity through the capillaries. Now that's a simple ratio. Basically, I can write that as this, right? That the velocity through the venules compared to that of through the capillaries would be a 4-to-1 ratio, right? The volume through the venules is 4 times larger than the velocity through the venules is 4 times larger than the velocity here through the capillaries, which is 1, all right? So now, just keep that in mind. So now my goal here is I'm going to move back to the question, and the question's asking me, find the total cross-sectional area of the capillaries. So I'm after this variable, right? So basically, this should be simple algebra now, right? The total area of the capillaries will then be equal to the total area of the venules multiplied by the average velocity through those venules, then divided by the average velocity through the capillaries. So I'm just going to rework this now slightly. Watch, I'm just going to simply just shimmy this on over to the right a little bit. And what I'm going to do is I'm just going to put this little thing in kind of brackets. And look what we have here. I just didn't put the average signs, but whatever. And look at what we have over here. They're identical, correct? So now I can plug in and find the total area of the capillaries by knowing the total area through the venules, and they told us that. That's the 10 squared centimeters. Now I'm going to leave this in terms of squared centimeters in my calculation. Remember, though, that if I do that, this value will be then in squared centimeters as well. And the reason why I can do that is if you look, this is a simple ratio, right? That the velocity, it's velocity divided by velocity. So the units there cancel, right? So the only unit that is left will be the unit that I'm using for the area. So if I decide to use square centimeters, that's what I get. That's what I get that is spit out of the equation, all right? So here, this is just then 4/1. So obviously we see that the total area through the capillaries is simply 40 squared centimeters. Okay, now that takes care of letter A. All right, let's take a look at now letter B. So letter B is now saying how many capillaries are involved if their average diameter is 10 micrometers. So in order to answer this particular question, right, we would need to find the area of a single capillary. I'll write C(1), for this is a single capillary. If I know the area of a single capillary, and then I know the total area of all the capillaries combined, couldn't I just divide the two to find to find how many capillaries there are? Yeah, right? I mean, that's how we're going to approach this. Okay, so the first thing is I got to find out the total area, the area of a single capillary. So the area of a single capillary will be equal to, remember capillaries are cylindrical and the cross-sectional area is a circle. So therefore it's going to be equal to pi, the radius of that single capillary squared. Well, they told us the diameter. So first thing is, you know that if this is the diameter divided by 2 to find the radius, right? So the radius of a single capillary is going to be 5.0 micro. So 5.00 micro meters, right? 5.00 micrometers. All right. So now, that being the case, what I need to do is now convert micrometers into, what I need to do now is basically take micrometer and convert it into centimeter. Well, why? Well, remember, I'm going to eventually be dividing my value by 40, or I should say I'm going to be dividing 40 by my area of a single capillary. So I need to have consistent units here. So whatever unit I have over here, I better have that unit in terms of my area. Now the area, remember, is just a function of radius, right? So whatever the distance value of the radius is, that's going to be the distance value of the area just squared. So I need to convert this into centimeters. So let's simply take the 5 micrometers, all right, put micro on the bottom, micrometer on the bottom, put centimeter on the top. You know the prefixes now are 10 to the minus 2 for centi and 10 to the minus 6 for micro. However, when you do metric to metric conversions, all you have to do is just flip the signs now, and then you're going to get the right answer. Why is that the case? Well, that's for another video, but as long as you do this, you'll always be correct when you're doing metric to metric, prefix to prefix. All right. So this is now simply going to be 5 multiplied by 10 squared, then divided by 10 raised to the 6th. And what do we get? We get 5 times 10 to the minus 4, right? So now in terms of the radius value, this is going to be 5.00 times 10 to the minus 4, and this is now in centimeters, okay? All right. So now, here we go. So let's now do this. Okay, I'll box that answer. Now I'm going to plug that in for my radius over here. So the area of now a single capillary will be equal to pi multiplied by 5.00 times 10 to the minus 4 squared. So the area of a single capillary will now be equal to pi times 5 times 10 to the minus 4 and squared. So we get about 7.85 or so, right? 7.85 times 10 to the minus 7. And this is now in centimeters. This is now in terms of centimeters squared, okay? Now this is not the answer, right? This is just the area of a single capillary. So now to find the total number of capillaries, so I'll say the number of capillaries will simply be equal to now the total area that we found over here of the capillaries divided then by the area of a single capillary. So again, plugging this in, this is going to be 40, divided now by this number. I'm going to use the exact number when I do my calculation. All right, times 10 to the minus 7, and just plug this on into the calculator. So 40 divided by that exact answer is going to be equal to about 5.09, right? 5.09 times 10 raised to the, what do we have? 7 it looks like, right? 7. So this is the number of capillaries, okay? So about 50 or 51 million capillaries. All right, guys, so I hope this helped. Please help us out and subscribe. That'd be awesome. And we look forward to helping you with more problems. Take care.